Hello, and welcome back to the second part of our motion matching tutorial series. I'm Kalechi, Technical Product Manager here at Motorica, and today I'll be showing you how we can go through Motorica's Motion Factory to create a full motion matching dataset for your game's main character in just minutes. But first we'll begin in Unreal Engine because that's where the process starts. And here we have our sandbox project. Now this is really just a playground for us to test out motion matching implementations using Motorica animations inside Unreal Engine. And this will likely be released in the future as a reference. But when we click play, you'll see that we have our Motorica Manny just sliding around in A pose in the scene with no animation. And the reason there's no animation is because we really want to get the character movement down. We want to make sure that it feels responsive, feels great, and also has the full range of movement that we need for our main character. Now, this capsule is based on critically damped springs. It's based on a blog post by Daniel Holden. We'll probably link it in the description. And that's because for motion matching, we want some smoother turns, smoother accelerations, and the default out-of-the-box movement component doesn't typically provide those. So we've created our own component, which is based on critically damped springs. Now, this component has a wide range of movement. We can run forwards, as you're seeing. We can strafe. We can walk. And we can sprint. So there's a full range of movement there. And what we have now is our movement down, but we need to animate this character. We need to obviously make it stop T-posing or A-posing. So what we want to do is we want to take the movement settings and the movement parameters that we have in our engine, bring them to Motorica, and then generate a full set of animations with those parameters. And when I talk about parameters, I mean that we know what speed our character is running, walking, and sprinting at. And we also know what kind of accelerations and decelerations it's using and turn rates. So we can take that information, bring it to Motorica, and generate a full motion matching data set. And I'm going to head over to the web app now so you can see how that works. So here we are in Motion Factory, and Motion Factory is one of our flagship features. It allows you as a user to generate a full motion matching dataset of 200 plus animations in just a few clicks. Now, there are two workflows that we have for Motion Factory. There's simplified workflow, which is informed by a lot of research that we've done with motion matching experts. We've even spoken to some of the people that created the first motion matching systems. And what we've done is we packaged that knowledge and all that research into a feature that allows you as a user to come to us and say, I have this character that wants to do this, this, and this, and it's going to go into this gameplay system. Give me a full motion matching data set that will give me comprehensive coverage for this character so I can have it in a motion match system. That's what simplified mode does. Now, custom mode allows you to customize the system in a few different ways and get a bit more granular. I'm not going to go too deeply into the features of that because we're going to cover them in separate videos and future content. So we'll head into simplified mode, but just bear in mind that we do have a custom mode for different workflows as well. So if we head into simplified mode, we're going to be greeted with the character standing in an idle pose. Now, if I click get started, we're going to be asked to choose a style. And I'm going to stick with the normal male style for this tutorial, but let's say I wanted to use a different style. We have over 250 styles in the system, and I can search for any one of them here, for example, the zombie. Click preview, and I can see what the zombie idle style looks like, or the idle pose for the style looks like. Now, if I wanted to go even further and create a style blend, let's say I have the goblin, and I want to create a goblin zombie hybrid because I like the hunched over characteristics of the goblin, but I want to bring in some of the flailing, unpredictable motion of the zombie. What I can do is create a style blend, go here in the second slot, add zombie, move this to 70%, 30% blend to get 70% goblin and 30% zombie, click preview, and now we have this goblin zombie hybrid. You'll see more of the characteristics if it moves around, but currently we're just looking at the idle pose, but you can see the kind of shift in pose and a bit more zombie behavior in the style. Now, for the purposes of this tutorial, like I said earlier, I'm going to stick with the normal male style, but this whole process works with any style and any style combination in our system. But we'll go back to normal male style and click preview and advance to the next step where we're going to be asked to select the gaits that we want the character to move in. So as you'll remember earlier, we had a very robust movement system. We had one that could support walking, running, and sprinting. So we will select all three gaits, walk, run, and sprint. And the next step is going to be to choose the movement settings for these gaits. So as you'll remember, we could strafe while walking, strafe while running, but while sprinting, we can't strafe. So we're going to have those settings on as they are in default. And the speeds themselves, I'm going to stick with 1.3 for the walk speed. I'm going to reduce the run speed to 4 meters per second because that is in line with our character movement capsule. And I'm going to keep the sprint at 6 because that's also in line with our movement capsule. The next question is to choose the movement mode. So this is a bit of a hybrid between asking about what you want for the style and what you want for the movement system. This is going to change under the hood things like accelerations and decelerations and turn rates, but we abstract it to 3 values for the simplified mode just to make it easier for the user. Dynamic is useful for games like Fortnite, which need really quick twitch movement that's typically faster than a human would turn if you had the root motion of a human baked into the animation. Realistic is for most use cases and is what we recommend, but is good across the board. And sluggish is useful for certain characters like zombies or goblins or ogres, which need a bit more weighted movement. Now for this, we're going to use realistic because we're just making a normal male character. And the next step is asking about the path length. So the first 3 questions were really about the style and what you want the character to look like and how you want it to exhibit its motion in the animations. But the next 2 questions are really just about the system and how you want to implement the animations into your gameplay system. And the first question is to choose the length of your paths. Now we have 2 options here, long paths and short paths. So long paths are what you'll see traditionally in historical motion matching systems where you would go to the mocap studio, record a bunch of mocap in a relatively structured way, throw it into motion matching, and that would pick the right poses and animations. But what we've seen from more recent animation systems or motion matching systems is a short paths approach where you, instead of having 8 different turns in one animation, you'll have 8 different animations with 8 different turns. Now, we don't want to, be opinionated and tell you which one to use, so we just give you the option to use both. But you can choose long or short paths here, and both of these options will give you the exact same coverage. It's just going to structure the animations in a different way and slice them up. For this process, we're going to use long paths, but you can use short paths and it'll be the exact same, just obviously shorter paths. Now, the next step is the speed damping phase. So we're going to ask you how you want to change the speed of the character based on the way that they're moving, or sorry, the direction that they're moving. Because typically in a gate, when you're running forwards, you're not running at the same speed forwards as you would be running backwards or sideways. And if we don't have that in the animations, it's going to be a bit harder for the motion matching system to pick the right pose with the speeds being different in the actual animations themselves. So we give you the option to bake this information into the animations to make it easier for your motion system to pick the right poses. So for walk, we're going to enable it, and we're going to put it at 90% and 85%. And these are things that I've set up in my movement capsule over in Unreal Engine. And for the run, we're going to say that when we're running sideways, we're running at 80% of our forward speed, or sorry, 85% of our forward speed. And when we're running backwards, we're moving at 75% of our forward speed. So once you've chosen all your settings, you have the review phase just to make sure that you haven't missed anything, and you can check that everything is set up correctly. And if it is set up correctly, then you can move on to the next step, which is the path viewing phase. Now, what this is going to do is it's going to show you all the animations that you're going to generate in your motion matching dataset, but it's going to show you the root motion of those animations, and you can preview the actual animation if you click this button here. So we have our different categories. We have idle, walking, running, sprinting, and transitions. Inside transitions, we have each pair of gaits. So we have walk to run to walk, run to sprint, so on and so forth. And inside gait category, we have different categories inside there. So we can go for running, forward, and we can see we have this animation, which is all of our run, start, stop. So we're running forward, start, stop, then turn left and stop, then turn left 90 and stop, so on and so forth. We also have the strafing animations in here for the for the run gait. But inside the sprint gate, you'll notice that we have less subcategories. And that's because we chose not to strafe in sprinting. So we have less animations and a lower range of motion because we don't need to sprint in our character. So one thing you'll be thinking is, okay, I have these animations, but I have a left turn 90. What if I need the same turn, but I need 2 different versions of that? One with, let's say, the left foot planted and one with the right foot planted. Because in game, we don't know what foot is going to be on the ground when we click left to turn left. So we need our animation system to be responsive enough to cover both cases. Now we have a feature called phase shift, which covers that. So you'll see here, if I click preview, this is our animation, which has all of our 90 turns. So we have 45, 90, 135, and 180. And we just have the one variation. So here we're pivoting on the left foot, here we're pivoting on the right foot, and so on and so forth. But if I click this button here and click 2 variations, then preview, we now get 2 versions of the same animation. But you'll see that we're pivoting with different feet. So we have the left foot down on this side, but the right foot down on this side. Then on the 90 turn, we have the left foot down on this side and the right foot down on this side. So it goes through all the different turns and it makes sure that we have the coverage on both feet for all the turns. And this feature works for any animation. You can use it for strafes, turns, starts, stops, all of those to get the different variations that you might need for your system. But why stop there? We can go for 4 variations. And this is going to give us not just the left foot plant and the right foot plant, but also the passing phase animations as well. Now, if you want to go this granular and you can add these to your system, then feel free. But, it's up to you how much animation you want in your system. Maybe it's a trade-off between performance, memory, and the amount of animation. But we just give you the tools so you can add more variations if you want to. So the idea of this whole path viewing phase is you'd go through the animations that you want. You can select to phase shift some of them. You can change the seed if you don't like a certain animation. You can make some animations loop and some animations not loop, but really just go through and make sure that the character that you had in mind is shown properly through these animations. You can go through 3 of them. You can go through all of them. It's up to you. And if you leave the page, you can always come back and you won't lose your progress. But let's say we're happy with the animations and we click advance to final step. Now what we're going to get is the final review phase. We're going to see how many animations that we're about to generate, and we're also going to see the style that we've chosen and the seed that we've chosen. So I just clicked generate, and after a few seconds, we got a ping back from the server saying that our animations are on the way. And this is telling us that in about 21 minutes, we're going to get an email to the email that we signed up to Motorica with, which is going to have a zip file. And this zip file is going to contain all the animations from this dataset generated and ready to bring into Unreal Engine or whatever engine you're using, but in this case, Unreal Engine. Now I can show you the structure of this animation dataset and see how we're going to bring it into Unreal Engine. So here we have our dataset, and you can see that we have the same categories that we had before. We have idle, walking, running, sprinting, and transitions. And inside these categories, we have the same subcategories that we had before as well. We can go for sprinting, look at forward, and see that we have all the same animations that we had before. So these animations are ready to bring into our engine, but you might think, we have to import them, retarget them, and then assign them to the correct post-search databases. There's a lot of effort from here to bring them into the engine if we didn't have the Unreal Engine import plugin. So what we have is a plugin that allows you to select the folder that you've just downloaded, tell the plugin to say import all of it, and we can import the animations. Then we retarget them to your target skeleton. Then we set up the post-search databases with all the settings like looping and root motion enabled, so you can drag them straight into your choosers and play straight away. Now, this is something that I'll be showing in the next episode of the tutorial, so do stay tuned for that. But we're done for this episode because we finished the Motion Factory setup and we're ready to bring our assets into Unreal Engine. So stay tuned and don't forget to subscribe so you don't miss the next episode where we'll be going over the full Unreal Engine setup, bringing the animations into the engine, putting them onto our character, and making it playable by the end of the episode. Thank you for watching, and I'll see you next time. Bye.